Section 4.1, Composite Functions, Part 1. Composite functions are functions that are made of other functions. When we see an example, you'll have a better idea of what I'm talking about. The notation for composite functions is f of g of x. Here, let me go ahead and highlight that so you know where I'm talking about, what I'm talking about. F of g of x, or we can also write it f of g of x. Please note that f of g of x does not mean f of x times g of x. Okay, let's go ahead and look at a composite function. Let's say we have a composite function, quantity 2x minus 4 squared. This comes from two different functions. It comes from the function x squared and g of x equals 2x minus 4. Why is that? Well, if I were to plug in my g of x function into the x value of f of x, then I would get the function quantity 2x minus 4 squared. And as we do more examples, this will become a little bit more clear. We haven't actually gotten into the meat of this, and so you might not understand yet what I mean by plugging in. Let's take a look at example 1 to better understand composite functions. Given f of x equals 3x squared minus 1 and g of x equals x plus 4, find f of g of x. First, I want you to note that we could write f of g of x in another format. It actually makes it a lot easier to see this way. And this is, coming from the above where I said f of g of x can also be written. It can be written in two different forms. Okay, so after, what I'm going to do is I'm going to first substitute the inside. So we're always going to work our way inside out. So we know g of x is x plus 4. So the first thing I'm going to do is I'm going to substitute x plus 4 for the g of x. So now we have f of x plus 4. Now this is something that you have seen before, the f of x plus 4, which means that we're plugging in x plus 4 into my x value of my f of x function. So what does that look like? Well, we have 3 quantity x plus 4 squared minus 1. Again, this is where, so right where I highlighted, this used to be our x squared function in the 3x squared minus 1. So I plugged in x plus 4 into the 3x squared minus 1. Okay, and then the next thing we want to do is simplify. So we FOIL the x plus 4 quantity squared. We get x squared plus 8x plus 16. Go ahead and distribute the 3. And then finally subtract the 1 from the 48. And we have our final answer. So that is our quadratic function f of g of x. Go ahead and pause the video and see if you can do number or part B. Hopefully you got a chance to do part B. So again, the first thing I'm going to do is just substitute f of 1. That means we're plugging x equals 1 into our f function. So recall that our f function is 3x squared minus 1. So all I'm doing is I'm plugging in. So plug in x equals 1. Okay. That's all I'm doing. So we have 3 times 1 squared minus 1. Go ahead and simplify that. And you should get g of 2. All right. So 1 squared is 1. And then 3 times 1 is 3. Minus 1 is 2. So go ahead and do that. And then now we have g of 2. That means now that we are plugging in x equals 2 into the function g of x. So now we're substituting 2 for x. So we should get 2 plus 4. And then go ahead and simplify that. And your final answer should have been g of f of 1 equals 6. Now, what if you are not given functions and algebraic functions, and instead you're given graphs. Let's see how we would do this problem. Okay, the first thing, note that the red graph is g of x and the blue graph is f of x. That's going to be very important so that we know which graph we are looking at. Okay, so first, again, we're working our way inside out. Let's look at g of 2. That means, and this we've done before, just the g of 2, not the f of g of 2. But that means we look at our g graph because we're looking at g of 2. And the 2 is our x value. So let's go ahead and look for x equals 2 in our g graph. Okay, and I'm going to highlight it red since our g graph is red. So here's 2. I'm going to dot it. Okay, and then we have the point 2, negative 1. So g of 2 equals negative 1. So let's go ahead and write that. And then after you do g of 2 equals negative 1, we can now do f of negative 1. So now we're looking at the f graph, and we're going to do that one in blue just to stay consistent with our colors. So go ahead and find x equals negative 1. Okay, and we're going to go up to our f graph. So notice that the point there is negative 1, 1.5. Therefore, f of negative 1 is equal to, if you said 1.5, then you are correct. And that is our final answer. F of g of 2 equals 1.5. Now let's go ahead and do B, or if you'd like, press pause, see if you can do it yourself. Now, I like to rewrite it as f of 8. So again, let's find f of 8 first. So we go all the way to x equals 8, and we go to our blue graph, not our red graph, right? Because we're looking at the f. And then we have the point 8, 1. Okay, so now go back and substitute f of 8. So f of 8 we now know is 1. So go ahead and write that down. And now we're looking for f of 1. So again, go to x equals 1 and see what the point is at x equals 1, and that's 1, 2.5. Okay, so what is f of 1? F of 1 is, if you said 2.5, then you are correct. So f of 8 is equals 2.5. Finally, let's go ahead and take a look at C. Again, you can press pause and see if you can do it yourself. Let's go to f of 9. We have the point 90, so f of 9 is equal to 0. And then after we do f of 9, we're going to do g of 0. So now we're looking at the g graphs. I'm going to change this to red. So at x equals 0, we have 0, negative 2 for the g graph. So g of 0 equals what? If you said negative 2, then you are correct. So g of f of 9 equals negative 2. And we will do example 3 in our second part of this lecture.